For decades, the 1-mile-wide Golden Gate Strait was considered impossible to cross. Before the steel rose, the only path from San Francisco to Marin County was a slow, perilous ferry ride.
Many experts declared a bridge could never survive the ferocious winds and 372-foot deep swirling tides.
Overcoming immense opposition, funding was secured, and the impossible project was greenlit.
On January 5, 1933, the monumental battle against Lacher began.
Thousands of men descended upon the bay, ready to build the longest suspension bridge of its time.
Work commenced on the marine side, anchoring the North Pier directly into the solid rock.
But the San Francisco side posed a deadly challenge, building the South Pier in the open ocean.
Brave divers plunged into the freezing, pitch-black currents to set the explosive charges. Working blind in treacherous tides, they leveled the bedrock 100 feet below the surface. Explosion after explosion carved out a massive crater in the ocean floor.
To build the pier, they first had to construct a massive, watertight concrete fender.
This underwater fortress would protect the tower from ship collisions and brutal waves.
Once sealed, the ocean water was pumped out, leaving a dry void in the middle of the sea.
Inside this dry chamber, the base of the mighty South Tower was finally cast.
With the foundation set, the true ascent into the sky could begin. Next came the steel, 117,200 tons of it. Ironworkers, the cowboys of the sky, began assembling the 746-foot towers.
Over 1.2 million steel rivets were driven by hand to hold the mighty towers together.
Each rivet secured the bridge's fate, battered into place by sheer muscle and steam. The massive Art Deco structures were built in a cellular design, capable of flexing in the wind.
The towers grew taller, pushing through the dense San Francisco fog. The higher they went, the more dangerous the fierce coastal winds became.
Working up to 70 hours a week, these men wrestled the steel into submission.
Finally, the two tallest suspension towers in the world stood complete. Now, they had to connect them. It was time to spin the web. The strength of the bridge relies entirely on wire no thicker than a pencil. First, a delicate guide rope was stretched across the treacherous strait. Then, the ingenious cable spinning process began. Traveling back and forth, spinning wheels carried individual wires across the expanse.
6 months of continuous spinning wove 80,000 miles of wire, enough to circle the Earth 3 times.
Hydraulic jacks compressed the bundles into 2 massive main cables. Each completed cable contained 27,572 individual strands of wire. These 2 cables would carry the entire weight of the suspended roadway. Heavy steel bands were locked into place to secure the vertical suspender ropes. 250 pairs of vertical ropes were dropped, waiting to lift the road from the sea. Suspended under the floor, it was designed to catch anyone who slipped. But the net did its job. 19 men survived fatal plunges.
These survivors became legends, forming the exclusive Halfway to Hell Club.
Tragically, the net could not save everyone.
In February 1937, a massive scaffold fell, tearing through the net and taking lives with it.
11 men died during the construction. Their sacrifice is woven into the steel. Despite the tragedy, the work pushed forward relentlessly. Building the deck was a delicate balancing act.
Crews had to build outward from the towers equally to keep the weight balanced. Section by section, the 1.7-mile roadway was pinned to the suspender ropes.
The massive steel truss system was designed to flex and twist in high winds. Welders and riveters and fused the skeleton of the highway.
When the center span finally connected, the Golden Gate was officially bridged.
The structure was whole, but it still needed a floor.
A massive grid of steel rebar was laid across the entire 8,981-foot expanse.
Then, the grueling process of pouring the concrete roadway began. The deck was paved to carry 6 lanes of heavy traffic. The bridge needed protection from the harsh, salty sea air. The U.S. Navy wanted black and yellow stripes, but architect Irving Morrow had a better idea.
He chose a vibrant vermilion, known as International Orange. The color perfectly complemented the landscape and, crucially, cut through the thick fog.
Elegant Art Deco streetlights and railings were installed to complete the aesthetic.
To guide ships blindly through the mist, air-powered foghorns were mounted.
Red aircraft warning beacons were placed at the very peaks. After 4 years of grueling labor, ahead of schedule and under budget, the impossible was done.
The $35 million marvel stood ready for the world.
On May 27, 1937, Pedestrian Day, 200,000 people flooded the roadway.
The bridge instantly transformed the region, carrying millions of vehicles. Over the decades, the bridge was constantly upgraded and retrofitted to withstand earthquakes.
Seismic isolators were added to ensure the structure survives the San Andreas Fault.
At night, the bridge is transformed by carefully designed architectural lighting.
Movable median barriers dynamically shift to handle the crush of daily commuters.
It remains a vital artery, carrying over 112,000 vehicles a day.
But nature constantly challenges the steel giant. The bridge is never truly finished. The salt air eats the steel alive. A dedicated team of ironworkers and painters fight a never-ending war against corrosion.
Painting the bridge is a continuous, year-round task.
In the 1980s, the entire concrete road was replaced with lighter, stronger steel panels.
This massive deck replacement happened at night, without closing the bridge to traffic.
New wind retrofits allow it to withstand even greater storms, up to 100 miles per hour.
Every inch is inspected, reinforced, and maintained by brave crews.
The iconic foghorns still blast blindly into the mist, guiding giant freighters to safety. The bridge stands tall enough to allow the world's largest ships to pass beneath. In recent years, a crucial new feature was added to save lives. Massive steel safety nets were constructed beneath the walkways. Through it all, the 80,000 miles of wire hold strong. The 1.2 million rivets still bear the weight of history.
Today's engineers use digital technology to monitor the health of this analog giant.
It is recognized globally as a wonder of the modern world.
The brutal currents still attack the base, but the underwater fortress holds firm. It is a bridge built by brute force, maintained by modern science.
Built in an impossible location, against impossible odds.
Inside the cables, tens of thousands of wires act as a single, unbreakable muscle. The vertical suspenders transfer the crushing weight of the road directly to the towers.
The cellular steel towers are hollow, filled with a maze of ladders and maintenance walkways.
Deep inside the steel, inspectors search constantly for stress fractures. Massive shock absorbers allow the deck to swing like a pendulum during an earthquake.
The infrastructure around the bridge is a massive operation of its own. Every component is supersized, engineered for maximum redundancy.
It is the ultimate gatekeeper between the San Francisco Bay and the Pacific Ocean.
Became the greatest engineering triumph of the 20th century.
The sea still tries to tear it down every single day.
The sun and fog endlessly attack its steel skin. But as long as there are men willing to maintain it, the Golden Gate Bridge will stand.
A testament to human will, engineering brilliance, and brute factory strength.
This is what it takes to build the impossible.
This is what really happened inside the Golden Gate Bridge project.